Alright guys, so I've done 3 of these already. The 4th one should be just kind of the same thing all over again. Okay, so I'm going to try to go through this one a little bit faster so that the video doesn't take quite as long. And if you really need help, then look back at the other 2 and see if they kind of can give you a few more specific instructions. Alright, so here we go. This one, I'm going to go substitution first, just like I did in the other 3. Alright. So substitution, I isolate a variable, y is all by itself, so that means x minus 3 can replace the y here. So I go x minus 3 equals 2x squared minus 3x minus 1. Being that it's a quadratic, I want it equal to 0, so I'm going to move the x minus 3 to the other side. So to do that, I'm going to subtract x and add 3. That will cancel out everything over here, giving me 0 equals 2x squared minus 4x plus 2. At that point, I'll go ahead and check to see if I can factor this. It sure would be nice if I can. So factor, it's going to have to be a 2x and an x, because 2x times x gives me x squared. Because it's a plus and then in the middle a minus, I need 2 similar signs, but to get me the negative, it's going to have to be minus, minus. Now it's really tempting to put the 2 here, because 2 times 2 is 4, but then I'm also going to have a 1 times x, which isn't going to work out. So I'm going to put the 2 here and 1 there. 2 times 1 is 2. So negative 2 times x will be negative 2x, and 2x times negative 1 will also be negative 2x, giving me the negative 4x that I'm supposed to get. So therefore 0 equals 2x minus 2, or 0 equals x minus 1. Now you may have noticed, if I would have been paying closer attention at this point, I could have divided out a 2, which would have left me with just an x squared minus 2x plus 1. That would have been a little bit easier to deal with. Unfortunately, I didn't do that, but it's okay. I'll add 2. I got 2 equals 2x. Divide both sides by 2, and I get 1 equals x. And you'll notice that if I do the same thing on this side, I still get 1 equals x. Now what that means is that I only have one intersection point, because the x value is the same. Now remember, to get the actual intersection, I need to take that x value and put it back in. I'm going to put it into the linear equation because that'll be easier. So x equals 1 minus 3. That would then be y equals negative 2. So the only intersection I have is when x equals 1 and y equals negative 2. According to substitution, that's what I ended up with. Alright, so let's go ahead and do the graphing. So we go, and we'll go ahead and do graphing now. So first I'll do the linear graph, which I'll go ahead and do in red. So I start at the negative 3, and then the slope is up 1 over 1. Alright, so there we go. Put my points down, make sure that I hit as many as I can. I keep going, right? The more points that you have, the easier it'll be to pick off your final answer in the end. Make sure your points are big enough that you can actually see the points there. I think that'll be helpful to you in the long run. I know sometimes it's a little bit tough on OneNote because the big dot, sometimes it thinks you're just holding it in place. But, you know, you should be able to kind of figure it out so that you can get some decent sized points there so you can see all the points. So there's my line. Now I'm going to go ahead and do the quadratic. The first thing I'm going to do is to find the axis of symmetry. Axis of symmetry is at x equals negative b over 2a. So negative b, remember this is just ax squared minus bx plus c, not 3c. So plus bx, b is then negative 3. And then over 2 times a is 2. And so I end up getting, ooh, that's going to be fun, 3/4. It's a fraction. Yep, it's a fraction. Deal with it. So 3/4 is the x value, which then, of course, will be, I'm going to need to change colors now. So 3/4 is somewhere around here, a little bit closer to the 1, not right down the middle. Okay, so somewhere around here. That's going to make reflecting a little bit harder, but you know what? We can deal with it. All right, so next, why don't we find out where the actual vertex is. So we'll put 3/4 in for x. And as much as I love fractions, I really don't feel like solving this right now. So let's go ahead and I'm going to pull up my calculator, and I end up getting negative 2.125. So 2.125. So somewhere around, somewhere around here, somewhere around there is that point. Come on, dude. All right. Now from there, I'm going to go ahead and get a few more points. It looks like I'm probably going to get some x-intercepts. Let's get x-intercepts. So x-intercepts when y equals 0. So I'm going to go ahead and put in 0 equals 2x squared minus 3x minus 1. Again, I'm going to go ahead and try to factor this if possible. I've got 2x and x. I've got a minus here, which means a plus and a minus. And then it's got to be 1. The only option really I have is 1 and 1. Unfortunately, when I try that, I'm going to end up getting negative 2x and positive x, which of course is just going to give me a negative 1x and isn't going to give me the negative 3x that I was looking for. So my vertex is going to be somewhere else. Sorry, my x-intercept. I can get it through the quadratic equation. So I'm going to go ahead and do that. X equals negative b plus or minus the square root of b squared minus 4 times a times c. If you need to pause, go ahead and pause at any point in time to kind of figure out what's going on. Like I say, I'm going to go through this one a little bit quicker. I've already done 3. At this point, I'm going to go ahead and pause, work through it on my calculator. Alright, when I work this out, I got x equals 1.78 and x equals negative 0.28. So if I put those down, 1.78, so around here, 1.78, and then negative 0.28, which is about a quarter right there. So you can kind of see what this is starting to look like, something like this. Alright. Now I go ahead, I'm probably gonna, I guess I can get my y-intercept as well. So I go y-intercept at x equals 0, and I put 0 in. I get y equals 2 times 0 squared minus 3 times 0 minus 1, and I get y equals negative 1. So at y equals negative 1, that's my y-intercept. That can reflect to the other side, which should reflect somewhere around here. Note that it's going to be a little difficult to reflect that just because of the axis of symmetry being kind of not right through the middle, but that's pretty close. I got about 3/4 on each side, and so there we go. We've got some kind of graph here. Note that it's pretty difficult here to see exactly where the line is crossing, but it's got to be somewhere around here. Alright, so right then you can estimate, you can make a guess. You know what, my guess is that chances are, even not knowing this, if Mr. Bywater isn't purely evil, then probably what he's going to do is he's going to give me this point, which is 1, negative 2. So I'm going to guess 1, negative 2, because it's the only point right on the grid right there that looks like it could possibly be an intersection of those two. Alright, so with that, I could always just then check it in both equations and show that it actually works. We already know that's the answer because we solved for it in substitution and it works out. But you could put it into both equations, show that it works, and that then would be a proof enough for me that by graphing we've shown that the intersection is at 1, negative 2, and that there's only one intersection. It just touches the graph there. It doesn't actually cross the line, just kind of touches it and continues going. So there you go. That's our final question for tonight. We are done.